Adam Savage here in my cave. We are adding to my tool collection today due to a generous gift from tested patron Lee Marsh, who gifted me this magnificent Boley Linen Watchmakers Lathe. It has a cross slide, it has a tailstock, it has a sensitive drilling rig. He sent it with a bunch of collets. This is a few months ago, and I have been slowly adding to the collection of making this thing usable. And just to, like, a lathe is a machine for spinning something and acting upon the spinning thing. Watchmaker's Lathe is no different structurally than my giant 15 by 40 inch tool room lathe. My tool room lathe has a bigger swing than the entire length of this lathe. And I'm really excited about what this might be able to bring to my process. Now, when you have a small lathe, you turn it with a belt like this. And this is the belt that drives this. I think this is a 4mm. I can't quite tell. Anyway, there are belts, there are positions. There's a motor, which I have just recently completed restoring. That video, we'll have a link to that in the description. But between this motor, its little pulley shaft, and this lathe and its little pulley shaft, I can utilize these two pulleys in order to get a range of some speeds. But I'd like a bigger range of speeds. Enter a key piece of equipment in the Watchmaker's Lathe repertoire, and that is the countershaft. Now, this is a really remarkable little bit of engineering because this thing has multiple pulleys on it. This one even came with a little grinding stone that you can do tool adjustment on. Like, you can actually grind some of your lathe tools. I want this to be part of this process. I want the countershaft to be between the motor and the lathe. And because the countershaft has the shaft and the pulleys are movable and lockable upon that shaft, I may even go so far as to mill a flat on this shaft, simply to have a little more of a positive transfer of power. At any rate, yes, I'm going to mill a flat on that shaft. So I'm going to take this beautiful countershaft, this beautiful motor, and this really beautiful lathe, and I'm going to get them in an orientation that works for them today and allows me a much wider range of speeds for my Watchmaker's Lathe. I've got this beautiful little Racine jeweler's lathe motor. It spins magnificently. It's got a nice amount of torque at the high end. This was another gift from a fan. Thank you, guys. This is so exciting. And one more thing on these. You will notice here, if you look carefully, that there's these two little things up here with twisty tops. Little that. And those are oilers. This is a pair of pressure cones creating the lack of any kind of slippage or vibration. And there are holes here for similar things. And I'm going to fill those with oilers too. I think I'm going to swap out this belt with some of this stuff. So we are remaking our belts for the lathe. So by the end of today, I'm hoping to get a lathe in which I can do a nice high torque, low speed and a super high speed. Those are the two goals. You're going to have to take my word for it, or we're just going to figure it out together, because I don't think I have a tachometer in here. I might have a tachometer. I'll have to go look at an old meters cabinet, but I don't think I have a tachometer that can tell me my exact speed, but I can get close. And again, Watchmaker's Lathe, from what I've been able to glean, is that the practice of using a small turning center like this is that there's a wide range of speeds that material can be acted upon within. I'm dipping my toes in here. So I think that I shall never see. I think I'm going to get a piece of wood in here that's much closer to what I actually want. that's definitely going there. And then this, all of this stuff can move around. I may be able to shorten this, but I'm not going to worry about that until a minute from now. And then this guy would live here, where this can affect either side of this if I so choose. Okay, so this guy can sit here and adjust this way to tension. I think traditionally, I think really what it needs to happen is that can't come out farther than that. So that has to live there. That provides this amount of room connected to the pulley. And this could move over here. This could be here. I suppose if I absolutely had to, I could also power off of this side. Put this side, well, okay, so I could put this here and then I get everything. Forward, reverse. Let's try that. Okay, let's talk about what I've just done, because it was easier to tell you after the fact, I think, than before the fact. But what I've got here are very repeatable, reconfigurable version of hold downs for my various pieces of the jeweler's lathe. So first things first, this guy lives here, and he goes down with three 832 brass screws like that. And then, and for each of these, I have actually installed a threaded insert, an 832 threaded insert, so that I have a positive, repeatable thread that I won't munge. These two also go in here like this, and I'm going to get a flathead screwdriver. These work. Let's see here. Yes. Okay, and then for the motor goes like this. So this plate goes under the motor. It attaches to the motor, and those are the threads. But that whole thing is sandwiched here so the motor can move back and forth to adjust the final tension. That's the goal. So let's get this up. And oh. Okay, so that's in. And that's it. Okay, so let's just like test operation here. If I loosen that and I loosen that, then I should have the ability, yep, to move the motor back and forth. That's great. And then when I clamp it down, I have a very nice positive clamping mechanism because I'm sandwiching the whole board between the motor and that. So then the countershaft lives here, right? Okay, I am totally going to mill a flat on my countershaft. This is the belt it came with. I am going to eliminate that. Oink. Yes. I'm going to replace it. Well, I'm not getting rid of that, but the same gauge belt. I'm just going to assume that whoever operated this before I owned it would have the correct kind of persuasion on here. Great. So we're going to try sealing this one first. All right, I think this is ready to go. I'm going to trim off its excess here. Okay, now the second one. Oh, I see. This is interesting. Yeah, I've been getting the relationships a little bit wrong. Okay, so that doesn't work. I need this to be more upright, especially since, yeah, it's got to be vertical to clear that and that. And frankly, I feel like I should rise it up. All right, I've tried to make this 6mm belt stuff work, but I don't think I'm having clearance issues everywhere with it. So I'm going to stop mucking about with it for right now and go to the 3mm belt, which from what I understand should work just fine. So let's try that. I totally forgot to film, damn it. I just joined two belts I just told you not to take my advice about how to join belts because, like, that right there is like the third time I've ever joined one of these belts. Anyway, there's a whole YouTube channel called I Thought I Was Rolling. That one feels pretty good. Now let's do some trimming. Oh, that didn't work at all. That was a totally shite join. So, then we'll try that again. Here we go. This is the first test fire of the unit with all the belts going. That's great. I'm pleased with that. I feel like I could get rid of that. I feel like I could go a little bit farther. Here we go. Okay, I want to try a higher speed. So let's try. So we're going to loosen this so I can pull it back. We're going to move this to this. Move that there. This back. Oh, shite. It is not far enough. Darn it. Really? Why are you having so much trouble? This might not be the right motor. To recap where we were, I am attempting to make this beautiful jeweler's lathe sing. And what it needs is rotational energy. I first thought I might obtain that rotational energy from this beautiful little old motor. It's got a little bit of vibration in it. It's noisy, like that kind of thing. Stop it. I really wasn't willing to live with. And then I had this other motor. Where is that one? I had this other sewing machine motor, but it was also underpowered. One of the issues with the jeweler's lathe is that at low speeds, you have very, very low torque, and that's difficult. So in order to get what I wanted out of this, which was a motor arrangement that was as quiet as possible while being as robust and high torque as possible, I picked up a cheap brushless servo motor here from Amazon, and this is perfect. You listen to it at This is it at 3,200 RPM. 3,500 RPM. That's great. I can do all sorts of programming of its parameters. I don't have to make it foot pedal operated, which I didn't want to do. I can actually put a lever on this and I can just have a little settable, kind of tunable speed control. It's great. Everything about this is great. There's going to be a few things I need to do here, and that is to pull this motor off, remount it, mount it on a movable slide, machine a pulley for this that actually will fit with this, or somehow make this work on there. That's also a possibility. There are a few things to do. This is not the quick and dirty Adam puts a motor on his jeweler's lathe video I thought it was going to be. Shockingly, it's going to take another day. What? Simpson? I just love these steamed hams. There it is. It's that. That's where I went wrong. I have the, let's see, I have this mounted, and, hang on. It's lovely and quiet. Very happy with that. But now I'm going to turn this aluminum shiv down to match this one. Give or take. To the lathe. We're going to have James Gunn come and do some building in the shop, just not say anything. Every time I see a photo of him in the news, I think it's me. That should give me what I needed. That's my new shiv. Shiv. S-H-I-V. S-H-E-A-V-E. Sheave. And that means a pulley. And when you're working with riggers, they'll often say shiv, and they don't mean a knife, and they don't mean Sarah Snook. They mean a sheave. They mean a rolling pulley. One of the 6 simple machines. So now I think we're almost at the spot in which I can, yeah, we're gonna go there. Lovely. Now, I love how quiet that is. So now we're going to pop in our friend. Is it clear here? Yes. It does. So if I turn this on, what is that terrible sound? I need to investigate. Ha! Okay. Oh, maybe that's it. Hold on, maybe I wasn't paying attention to it. Simple dumb thing. Let's try that. Yep, that was it. It was the I'm ridiculous. I am ridiculous sometimes. This is much easier. Right. Oh, right. And I guess if I have to go to smaller versions of this, right now I'm getting about a 1-to-1, slightly less than 1-to-1. So if I'm running this at, 3,500 RPM, I'm probably getting 3,000. I can get much lower than that with plenty of torque. So, that would have to be moved with spacers, right? Mm-hmm. No, I'm being silly. It's much easier than that. I know, I've got the small one on the big one, on the big one on the small one. That's silly. I have my new position for where the lathe goes, and it's gonna go here, and I'm gonna then slice this off. Yeah, it's all gonna happen. Are you not enough? This. Now, here's what the hell does this work? Lots of torque. Tons and tons and tons of torque. Can't stop it. I could turn it at 5 RPM and not stop it. And that's like, that's not 3,500 RPM, even though this says that it is. It's probably like, with a little bit of tension, it's less, but still, that's great. So, I feel like great. So the whole distance this thing travels is not crazy far. It's like, that's the start. And that's the end. It's only an inch. All right, I've got an idea, and it's going to take me some taking apart some stuff and some putting stuff back together. Yeah, right, but it should work. That's my Jim Jeffries. Oh, I really like guns. All right, I've got this on the run. This is my specialized motor stand. It's got all sorts of extra attachments to it. I'm about to give it some attachment for the switch. The switch lives here and gets attached like that. Okay, so this is the switch. It goes like this. Now, to activate this switch, I'm going to give myself not a foot pedal, but an actuator knob. And watch how this works. So this goes in here like this. I love big chunks of threaded. I love big chunks of threaded Delrin. Here is the knob, and it comes in here. Where it rides on there. Look at that. Okay, that's all ready to go. So now I want to attach this to the plate underneath. All right, so time to put on both the back of this and tighten it all down. Oh, this is very close. I'm very happy. I'm very excited. So I do this, and we do a little bit of that. Yep. Okay, so that gets that in order. Are we on? We are on. This is the worst. I'm on the last step, and this thing is completely hemorrhaging. Hemorrhaging in that I've got a brand new error. So it must be about how I attach some stuff. And I've got to open this up. It's like this is always like this. In doing this kind of thing, you end up accidentally tightening something too far. It hits a contact, and now you've got to go all the way to the bottom of the thing, kind of figure it out. All right, now I have the whole system separated out. Let's see what works. Ha! It up again. All right. No, I didn't. But now it all of a sudden works. So why is the question? And it could be a proximity of metal. It's certainly that something in my attachment got mucked up. So let's undo everything. Oh, found it. Found it. Did you check all the connections? Apparently not. So, okay. That would explain its intermittent behavior. That I had gotten bit or something. My fault. All right. Okay. So, little spoon, we're going to cut out the problem. We're going to test operation. Let's see if this works. Bleep that, please. All right, here we go. Plug you in. I should not get error 04 anymore. Turning on. No error. It's always like this. You always think that you're at the very, very end, and then everything goes to hell. Okay. This is officially a moment of truth. Hopefully it's also a moment of beauty. Now, let's give it a chuck. All right, so we can increase the speed by turning this. Good torque. Okay. That's wonderful. It was touch and go there for a second. I have one more thing I want to try. This is meant to be mounted underneath your sewing machine, and this display here right now is upside down. I suspect that I can open this unit up. I'm going to take the power out. I'm going to open this unit up and flip that display so that I can see. Yeah, so I can read it. Let's try that. So you're not going to live here. That's for sure. And living back there is ridiculous because that's where, yeah, I'm just going to have to make some adjustments. Okay, all right. Good. I think I have this on the run. All right, before I slap it all back together, we're going to do one operations test. Yeah, we're going to do an operations test. Much better. It really wouldn't be a build unless I did some actual machining. So let's try it. It was a thing. It was more of a thing than I thought it would be. This is great. This is just great. I could not be happier. That's great. I can really, yeah, I can affect some stuff like that. Okay, so, is that it? Are we done? Is this what we're gonna do something useful with my lathe to wrap this video. These holes you can see here are actually
what do you call it? Indexing holes for dividing 360 degrees into a number of different increments. And earlier in this video, I was spinning this and I didn't know that the alignment pin was sitting against this, and it was... What it did was it ground off the top of that. See that? That's no good. I'm going to resharpen that. Now I'm going to put it back in here. Go. You can see where it's scratched right there. So this will now go back to being, that's an indexing capture. Isn't that great? But it's got to live down there all the time, down there. That was not an easy one. I know there's already been a motor build for this, and then we tossed out that motor, and now this is the motor mount build. Well, now there's going to be a toolbox build around this build. It's going to be a process. One of my favorite bits from this from this lathe, this right here is a beautiful piece of engineering. I will eventually turn on centers because that's the real way to use this thing. But I just found it to be quite useful for machining brass and fixing a part of its own. In addition, when I want to hold on to sensitive work, I use these ER collets. They are really, really neat. You can see it as a tube of steel that has been cut in such a way as it is a giant spring, and it's great for clamping stuff. It does not damage stuff. The ER system comes in many iterations. I believe this is the ER32 system. I've also got an ER16, and then I discovered that you can get these in this size. Oh, ER11s, but wait. ER11s aren't even the smallest. Hold on, I'm going to hold up the smallest. Oh, look at that. It's so cute. It's such a cute little thing. So I just chucked in an ER11 to machine and fix that thing, and it worked beautifully. Really nice on center, very, very reliable. And this right here is a little, fits in here. It's a 40 millimeter, 8 millimeter Bully linen collet, and it takes the ER11s. Now, apparently, I ordered an ER8 collet holder, but I think that it's a long story, but an ER8 collet holder is on its way. This is my favorite part of discovering that you can actually use these expanding collets in this thing. That is really useful to me because I purchased a ER11 here, metric. Yeah, from 1 millimeter up to 7 millimeters and 1/4 inch and 1/8 of an inch. I think this is going to be a very useful addition to my shop for sensitive work. I just have to wrap my head around it. I've been doing that for months, but now I finally feel like I've got a kind of a bead on it. I'm going to put this back before I forget where it goes. Just take 2 of these in the morning and get rid of your headache. Thank you guys for joining me for this. Lee Marsh, thanks again for this beautiful piece of equipment. I hope to make it sing. I had trouble finding people using an 8mm lathe online, and then I discovered Chronova Engineering. Let me just give you a shout out to a great YouTube channel of some beautiful machining videos, watchmaking stuff, highly sensitive stuff, very self-effacing, very humble and beautiful. Chronova Engineering. We'll include a link in the description. Thank you guys for joining me for this lathe video. It's a new lathe for the shop. It was hard to get there, but I'm very pleased with where we got. I'll see you guys next time. Cheers.
Thank you so much for supporting us by watching this channel. You can support us at an even deeper level by heading over to tested-store.com and picking up one of our tested embroidered baseball caps. We got your normal baseball cap, we got your flex fits, and we got flex fit truckers. And we are just starting to play around with lots of new designs, so check back regularly. Thanks.